All right, so continuing on with 7.3 homework. Number one, we had to determine whether the triangles are similar and then explain our reasoning. So if we look at what we have here, we know that we already have angles that are congruent right there by vertical angles. And then we were given that these lines are parallel, which would give us that the alternate interior angles are congruent, and so therefore you can see that the answer that is given to us for number one is that yes, they are similar by angle, and then you can see that they have named the triangles Y, X, Z, and VWZ. And remember that yours may look a little bit different, but the thing is that you want to make sure that the Y is in the same position as the V, the X is the W, and obviously the Z is with the Z. All right, if we take a look at the second one here, same directions, looking to see if they're similar, and then if they are, explain our reasoning for it. And so if we look at this, the first thing I notice is that we have right triangles here. And so therefore, this is going to be a 3, 4, 5 right triangle. We can figure that out by Pythagorean theorem. And that this would be a 6, 8, 10. So we would be able to figure out those sides. And then if we want to look for the proportions of the sides, we already know that we have an angle, obviously the right angle to the right angle. We don't have any other angles, so we would need to then go to look for the sides. So if we look here, we have 3 to 3 to 6, which gives us a 1/2, and then we would have 4 to 8, which gives us a 1/2, and then 5 to 10, which gives us a 1/2. And so then you could see that our answer is that yes, they are similar. Once again, watching to make sure that however you start this first triangle, they called it BAC, so BAC, that we need to make sure that it is the same as over here, that we would start with D and then D and then F and then E, because we would need this D here is between the 3 and the 5 side, and this D is between the 6 and the 10. So that's what we used for our showing our proportions. So that's how we know where to start and then what order to go into. Obviously knowing that the A right angle and the F right angle have to be in the same place. All right, looking at number 3. If we look at this, there's nothing that they don't tell us anything about the angles. So then I would jump to immediately just looking at the sides to see if they're proportional. So if I start with the smallest one here, that's 6 over 4, which if we divide by 2 is going to be 3/2. And then this is going to be our next one here, 8 over 5, and then 12 over 8. If we reduce that by 4, that's going to be 3/2. But we can see that we have, even though we have 3/2 here and 3/2 here, we have one side that is not. So therefore, you can see that this is the answer, that no corresponding sides are not proportional. Okay, looking at number 4, we're looking, once again, we're not given anything about the angles. So knowing that, I immediately jump to the sides and we start with the largest one here, 20, and then the largest one over here is 8. And if I take and reduce that by 4, that is going to give me 5 halves. And so if we have 10, actually I'm going to go with the next highest one here, which would be 15. To 6, and divide by 3 there, that's going to give us 5 halves. And then 10, 4, and simplify by 2, and that's going to give us 5 halves. And so therefore you can see that, yes, that they are similar by side, and making sure that, you know, we have JL, so that would be JL right there, to SR. And so we can see that that was the 10 to 4. And just making sure that you have these in the correct order is important. And so next went LK, which was the 15. And so RQ is the 6. You can see 15 to 6 here. And then, of course, that last side to finish up. All right, let me go ahead and move on here to number 5 was multiple choice. Pretty straightforward with this one. If we look at it, it says that we had a line segment AB intersect line segment DE at point C. Which additional information would be enough to prove that triangle ADC would be similar to triangle BEC? And so now keep in mind that we would need either to be able to show that all of the angles are congruent, all of the sides are proportional, or if we can get 2 of the angles congruent. And so if we look at what we have here, we would already know that angle C is going to be congruent to angle C because of vertical angles. And then if we knew that this was that AB intersected DE, we would know that we would have this to this, but we really don't have enough information to get another side. So if we look at the choices here, angle DAC and angle ECB are congruent. Well, if we look at where those are located, DAC would be here and ECB would be here, and that really is not helpful. So that choice, we can go ahead and rule that one out. If we were told that AC and BC are congruent, congruent would help us prove congruency here, but doesn't help us prove similarity because we wouldn't know be able to figure out the proportions. Knowing that angle CBE is a right angle, that this angle here is a right angle, really wouldn't help us because we wouldn't have a corresponding angle over here. But what could help us is that if we knew C, if AB was parallel to, AD was parallel to EB, we could then be able to pick up another angle by alternate interior angles and would be able to say that the triangles are similar. Okay, looking at number 6. Number 6 is finding the measure here. And so if we look at this, we're going to be able to set up some proportions. So if we look at first identifying that the triangles that are similar, if we look at starting with X here, and once again, you could start wherever you want to, you just have to make sure that you follow that order in the second triangle. So starting with X would mean that over here we were going to start with J. And then if we went to Y in this one, to the angle that's 51, then we would have to go to K in this one, and then fall over to Z and fall over to L. So that's how we know, that's how we can pick up that the naming of the similar triangles. Now let's look at what we know to be able to figure out our proportion here. So if we look at what we have here, we can see that those markings off there so I can put new ones on. We could see that this here is going to be in proportion to this here. And this here is going to be that X. And so we're just going to cross multiply and divide, and that's how we get the X is 12. And then number 7 is going to be the last one I'm going to do on this video before it gets too long. So I'll have to switch to a different video. We're looking here to be able to figure out this X right here. So if we go to look at what we know, we would know that the 5 is going to be in proportion to the 3, and the X that we don't know is going to be in proportion to the 12. And so then when we cross multiply, that we're going to get that X is equal to 20.